So welcome to my new workshop. I say new, I've been in here about a year and it is a mess. So I haven't uploaded any videos or done anything on YouTube for a while, and I was meant to become a content creator. Basically, I moved up to the Highlands of Scotland, quite far away from anywhere that has any major engineering industry. So I had to kind of create my own business and work for myself. And I have a lot of interests and things that I want to make and improve on, and not enough hours in the day to do all of that. We've just had a baby, little baby Neve, and she's absolutely gorgeous, 10 months old, and takes up a lot of my time. And I spend most of my days either looking after the baby, building this extension out the back there. Forgive the state of the garden, but this place is being renovated. And in this workshop is a to-do list as big as, well, that notice board plus several other notes on the computer. And I am now finally in the process of getting this place sorted out. So just an intro into the sort of things that I make and do. This is my Onefinity Elite CNC machine, which I use to primarily make plywood products that are flat packed, things for the home and fitness products. And I sell those on Etsy. They were doing very well up until about late 2025. And for the last 6 months, the shop has been really struggling. I think that's a sign of the economy. My CNC machine is set up specifically for plywood products in general. I cut a lot of other stuff and do a lot of carvings. So I've designed and printed these specialized clamps. They're made out of ASA, and these work perfectly for holding flat plywood down on the machine. I'm actually really happy with that design. They were just an off-the-cuff design and they worked first time, and I do really like it when that happens. This is my primary dust boot over here. Now this piece of wood stuck on here to stop the motor releasing and dropping the spindle into the table, which is a sort of beta version design flaw that the CNC manufacturers had, but that's been changed now. The newer motors have a sort of built-in magnetic lock, or they're a different type of motor that doesn't release when it's not under load. Anyway, this is my dust boot that I designed. It comes in from the back and feeds out of this 70mm hose into this record power dual motor Cyclone with a massive metal drum underneath, which disconnects and comes away on a trolley with wheels on it. If I zoom in, this is a very quick and dirty video, by the way. It's not going to be very professionally done. I don't have a lot of time in the evenings, but if I pull that lever there, the barrel drops down and just wheels out. It fills up surprisingly quickly. I can't remember what gallon that is. I think it's a 120, but it fills up so quickly. I've got to do something about this vacuum, and I'll talk about this vacuum system in a moment. I'm going to come back over here to these dust boots. So when you're cutting with the CNC on different materials, if you're doing a carving, you need to have this kind of dust boot that moves with the spindle. So that's designed to just slide over the spindle and stay stuck on the spindle. This is a slightly smaller version, which has got a smaller outlet, or inlet, sorry. And this one is a from behind version with a magnetic release on the front, and it's a 70mm cross section all the way through. So that oval shape is calculated to be the same size as this round shape. And it's the most bulletproof dust boot that I've ever had. It works incredibly well. I had to cut a different product the other day, and I was expecting there to be sawdust all over the workshop, and nothing at all came out. I mean, look how clean my drive ball screws are. There's no, I mean, there's a little tiny bit of sawdust down there, but there's not really anything, not really a mess on my machine. Something else I was working on was the arm. So as I understand it, that type of pipe with the sort of metal coil inside it, it's not very good for laminar flow. And I was told that these sorts of pipes, these polycarbonate tubes, are much better, but obviously they're not flexible. So I was trying to come up with a way that I could have a rigid arm that comes across here to improve the efficiency. And this was one of the designs I came up with. I've learned a lot about 3D printing since making this, so I'm pretty sure I can come up with something better than this now. But that's got clamps for your 2 coolant pipes and your spindle cable to go through. So they'll be fully attached to the rigid tube. That goes over the tube, and as you can see, it actually moves. Let's see if I can. So that does, it's hard to do it with one hand. I am holding the camera at the same time. But that moves. I've since then decided that I can probably do better than this, but this is just to show an example of the stuff that I'm working on in the workshop. Now I will do much better long form videos and how-to videos of how to like do the designs on Fusion 360 and how to make some of this stuff. I'll just turn this machine on. But for now, I'm just doing a quick show around to let people know that I am back on YouTube, and I intend to start doing videos again and making lots and lots of products. There's a lot of stuff I'm interested in making and excited about, and it's about time I started sharing all that stuff again. So over here is the Record Power dual motor dust extractor, or shop vac. A lot of UK shop owners will recognise this thing, and I've made these modified one-way valves on the top because when you have 2 motors on, that's fine. It's drawing a volume of air through the system. But when you have 1 motor on, it draws air back through the other motor's exhaust port, which means it loses power. And since putting these on, I've tested it and I've gained an extra 10% of power. So I'm just going to quickly show you how those work. Let me turn the light on there. So I switch on the motor. Oh, it's not turned on. Let's go and do that again. Right. Let's switch on the motor. There. Right, that's on. Back over. And here we go. So just talk you through how this actually works. When you're 3D printing, you can press pause and insert things. So the design on this, the actual sort of bearing that holds this little shaft in there, if I zoom in there a little bit, it's designed as a square block so that you can just drop it in halfway through the print, and then that's all, it all becomes a single piece product. This metal bar is dropped in during the print as well, and that's there to stop these flaps from crossing over onto each other. And as you can see, it just sort of flicks open and then slowly closes as the air pressure drops. Now, there's one on each side. Now what you'll notice there is that when I turned this one on, that one closed very quickly. And that's because the backflow of air just pulls those blades down. So by stopping the backflow of air go through there, you gain an extra 10%. Now, a lot of the time if you're hogging, which most of you guys will know is roughing out, if you're taking a lot of material off whatever you're working on the machine, then you'll have both motors on and you'll be taking away as much dust as possible. But when you're doing the fine cutting on here, if you're doing a finishing cut, there's not much sawdust and most of it is really light. And at 2000 watts, you don't really want both motors on. So I run one single motor and I want that pull to be as efficient as possible. So this is actually all kind of designed to run off the one motor. The two motors is for just a turbo boost when you've got to remove quite a lot of sawdust. So everything is, all the pipe work and the head of the nozzle is all 70 mil. And that's to run off of one motor, because two motors is designed to go for basically 100 mil pipe. But yeah, that's a product. Those little one-way valves I am selling on my Etsy shop, and I'm going to promote those. Just another note, they are designed to have a Y-piece on here, and then I'm going to vent the exhaust from these outside, and I'll show you why. If you look at that wall, you can see all that black soot on the wall. That's the carbon dust, because that's where I used to have the extraction system set up. That black soot is the carbon dust that gets ejected from the brushes. So these are not brushless motors, and you get a lot of carbon dust coming into the air, which means I'm breathing all that in. So I do want this to be a dust-free workshop. So one of the next design projects I'm working on, which I am going to fully share on YouTube, is going to be to duct these outside the workshop. And I'll show you how I'm going to do that. It's the reason I've moved this entire unit over here is because I have this outlet. This outlet here vents the smoke from the laser. So I have a laser here, an X-Tool, very old X-Tool. That's my outlet up there. And this cabinet basically draws air in the bottom, sucks it out the top, so it draws it through this sort of honeycomb stuff and straight through. And it's a very, very good venting system. I don't get any smoke in here. I can cut layers and layers of wood in there on the laser. But what I've got to do is join the exhaust from the Hoover through here, through some quick release connectors that I'll 3D print and design, and then they're going to merge to that pipe there. Now here's the tricky bit. I have to merge 3 exhaust systems into one 100mm outlet, and I'm going to basically, the 3D printer, my X1 Carbon, which is over there, is going to get moved over here. This is going to get moved to the left, and there's going to be 3 exhaust systems going into one manifold in there. I have to come up with a very special design that makes sure that none of that air flows back in here, that it all goes outside. So the smoke, the carbon dust from the Hoover, and the fumes from the 3D printer, because when you're printing materials like ABS, it releases some nasty fumes. So I did do a video a few months back, about 6 months ago, showing how I made this. It didn't get a lot of views, it didn't get a lot of interest. As you can see, it is pure chaos in this workshop, and there's a lot of like organisational things that need to be done. I made a start on it by making these sort of tool hold-in systems, these drawers that hold the toolboxes in place and stuff, but there's a lot more to be done. and I'm going to be doing lots of videos on that. So, products, stuff that I make, gymnast rings being one of them. There's a bit of a fitness product theme and a wooden theme and a climbing products theme among a lot of the things that I make. So I don't know if anyone's interested, but this is what sort of started me on this journey of working for myself a long time ago. Well, it feels like a long time ago. About 5 years ago, I designed these one-way locking cam lock systems. There is a video on my YouTube that shows how these devices work. This is 3D printed aluminium. And this back plate here is 3D printed stainless steel. That's from a carabiner. The idea of these is, if you're into your training, gymnast rings, you hook 2 of these over the ceiling, you thread your gymnast ring straps through them, and they adjust to whatever height that you want them to adjust to. So you can do chin-ups, press-ups and dips in a few seconds from each other. And that's for a 1-inch strap, and that's for a 50mm or 2-inch strap. Obviously they work in pairs, and if you go through my YouTube videos you will see there's an older video from maybe 6 or 7 years ago of when I first invented this. I got it patented. I went through the whole pitching event thing, pitched it to Scottish Edge, like a Dragon's Den type thing, and they gave me £10,000 towards it. Coming over here, there's some prototype one-way valves for the Hoover. Yeah. And here are 2 mould casings or casting casings. These are made from plywood for concrete moulds. Now, you probably would think that you can't cast concrete in plywood because plywood is porous and absorbs the fluid, but I actually coated this in resin, and it's so forgiving that you can see I've even redesigned this. So I changed the shape of this mould and just added filler to it, then machined that filler down on the CNC and then put resin over it, and it worked perfectly for what I needed it for. So I was making these prototype kettlebells, and if you train then you'll know, but if you don't train then you won't know. But these have dents in, and these dents are specially designed so that the kettlebell sits like that on your wrist. Now, these are nothing new. There are kettlebells with flat bits, but I haven't used a kettlebell that fits on my wrist in a comfortable way that I like. So I first came up with this. I think they're like competition size kettlebells. So these match all of the size and specifications for competition kettlebells. And I made these about a year ago, tried them out, and I found that this area here, which is what I've marked, was hurting my wrist when I was doing some of the exercises. Now, it is possible to use it without hurting your wrist, but it gave me this feeling that I should really be making them with dimples in. And I stretched some of the shape, but these work really well. Now, it's got a plastic handle on temporarily because the beech wood is very expensive. This beech plywood, it's about 300 quid a sheet. It's 32mm thick as well. It's the most expensive plywood that I've ever bought. And I don't want to just keep putting pieces of it in prototypes. But eventually I'll be making these with wooden handles and the concrete will be black. And the idea is to make this really nice wooden handled finished product and start selling them in my shop. This is, of course, just a prototype and it's been bashed around a bit. There's a few air bubbles in there. So it might actually be that I 3D print the molds for these out of TPU because it's kind of rubbery, and then fill that with concrete. Just a little bit more information. It is possible to do that, as here is a hollow plastic kettlebell. That's the version 8 because I went through lots of different design iterations on these. You'll get a 10 kilogram, you'll get 10 kilograms of concrete in there. So the heaviest you can get is 10 kilograms. So how am I going to make these heavier? Because most guys like to train with between 16 kilograms and above, like getting up to 20 and 24 and stuff. So what I did was, buried underneath all of this stuff, was buy these huge steel balls. And this one here is 16 kilograms. They're in pairs. So what I was going to do is drop these inside the concrete mold. And this is one of those projects that's really for me. This is just for me. It makes me happy. But most of the stuff that makes me happy actually sells. There's other people that want this kind of stuff. So, and I know some of you out there will look at it and go, how will you manage the shipping? You'd be surprised what Parcel Force will send. Like, they're quite happy to ship stuff that's 20 or 30 kilograms. And it's, you know, it's still expensive, but it's reasonably priced considering the weight that you're buying. So this is all carved on the CNC, and it came out perfectly. Like, I cannot knock that machine. If you look, all of the detail that you see in here is done through the CNC machine. All of these trays I've 3D printed. That's just all the stuff that I pack for my Etsy shop, all the flat packed stuff. This is like the assembly area where I do a lot of the stuff. Coming over here, these are the flat packed bike holders that I sell. These used to be my flagship product, if you like. I was selling, I don't know, 50 of these a week in 2024, and I was making good money. I was doing all right. And then everything changed and online sales just got harder. I need to sort this out. At some point I'll be doing a video on me completely tidying this whole workshop and bringing in tool organization systems and stuff. The X1 Carbon, brilliant piece of kit. There's so many things I've designed to get me out of trouble with this. So many things, and I'm going to do a video on all of that. There's a lot of prototype products that sit here in this graveyard, things that I've toyed with and decided that were no good, or, you know, developed even further. Lots of different ideas. My design station, primarily use Fusion 360, but Autodesk Inventor is my favorite and go-to design software. And yeah, this is all rubbish and waste, and it all needs to get sorted out. So this is just a video to show, do a walk around my workshop, show where I am, explain why I haven't made a YouTube video for a very long time, and basically to say I'm back and I'm going to start making YouTube videos, hopefully once a month at first, and then maybe eventually once every couple of weeks. So thanks for watching.